Okay, good morning, guys. While I'm loading up the presentation, does anybody have any question? Remember that you have to click on the talk button if you have a microphone to talk. Otherwise, just write it in the chat window. Okay. Okay, so we're going to be covering Chapter 1A today. That's what I sometimes refer to as a blue chapter. Those are the two chapters that are spliced into the regular Malik book. So that's what we're going to be looking at. So last time we talked about Chapter 1, which is the regular Chapter 1, and this time we'll look into Chapter 1A. Let's see. Well, seems like it's just going to be three of us, no more people coming in. Well, I'm not even sure if anybody is watching or looking at these archive presentations or meetings, but probably if it's going to be just low attendance, I guess, then there is no point doing these. I know, when you have a larger group, somebody always going to do what helps them, and extra things helping most people in classes. But when we have almost 30 students, and we only have one or two or three of you that benefit out of it, then I'm not sure if it's going to work really going through this. But I mean, you guys should bring it up on discussion board and bring up that kind of a conversation with classmates to see if they like it. I mean, I can see the statistics, who watches, what time, how many times they're watching these. So I can see if somebody is really actively looking at these or not. But I haven't seen any kind of a conversation if it's helpful at all. But anyway, I mean, we do it one day at a time, and then we'll see what happens. Okay. So basically, the first that's going to be over Chapter 1, 1A, 1B, and 2. So it looks like 4 chapters. But many of these chapters are overlapping. So don't look at it as 4 individual chapters, because the concept really overlaps. But the main thing is that we cannot start programming until we understand how to design a code. So even if you look at the main book, the title of it is Program Design. So it's not a coding book. And that's what we're trying to talk about at the beginning of the course. Or theoretically, most people, this is their first programming course. So what we're trying to establish is that you have to design a code before you even start looking into the language. So in this chapter, you understand or basically go through the basic concept of what variables and constants are. And that's what you're going to see in the homework assignment relating to variables and how do we test programs. So we need to understand the concept, and we're still not really doing a particular language, but we're just try to understand the concept. Okay? So you can see this hardware, software, programs, programming, all these definitions are overlapping from chapter 1 that we covered last time. So that should be simple to go through for everyone. Okay. So the processing is data items may involve organizing them for accuracy or performing mathematical operations on that. So that's what you call processing. You process the information. So when we look at later on flowchart symbols, we're going to have a flowchart symbol for input and output operations when we are inputting data. And last time we talked about computers can only do one thing at a time. So when we input the data, what do we do with that? And that's when we were talking about the whole concept that we need to store that data somewhere within the computer, because the computer can only do things or one thing at a time. And then we talked about the whole concept of we need to process the data. So when we're processing the data, we're processing what's already been stored. So when we're storing something, we're loading it. And then we're fetching it from the stored location. And then we're processing that information. So processing going to be a rectangle shape in our flowcharts. So we can, just by looking at the flowchart, we can see that we are doing two different things: inputting, outputting, or processing information. Okay. And we're going to instruct the computer with basically programming language. So we're going to have to write the source code, and that's when we're coding the program. So coding the program is not computer science. It's really just writing the letter, like it's a modified English class, right? When you would change the rules, the grammatical rules of English, and you would just write a letter, a specific letter. So coding is not computer science. So that's where you have to take courses, and it will take many courses before we really understand what computer science is about. So in the first course, you might be coding program, and that's what we try to avoid by also looking at it from the design point of view. So when we coded the source code, we need to compile that. We need to look at that for synthetic errors. If the code, what we wrote, the source code, confirms to a particular syntax of the language. So when we're checking that, and if it checks out just fine, then we build an object out of that. And that object code going to be basically interpreted by the computer. So the object code, the machine language what I showed you last time, that ugly thing when I moved AX0 and A moved A low 3 and A high, I moved 5 into it, and then I added A low to A high. That ugly language is not very user-friendly. That's like the assembly language. And below the assembly language is what you have the machine language. So what the machine understands, when the machine turns on and off the zeros and ones. Because we talked about last time, computers only understand zeros and ones, which we call the binary information. So going from the source code to that binary information, in between we have this compiler, the interpreter. The interpreter who reads our source code, checks for syntax errors, and converts the code into binary code with some other steps as well. So now we have a code, and then we need to execute it, right? So so when we compile something and we have the binary code, that binary code is stored in secondary storage. So that's when you store it on your hard drive or your thumb drive. That's not running program. So even if you receive an email has an attachment, and some people say, you just received a virus. Well, it's not going to do anything. That virus, that attachment is not going to do anything until you execute it, until you run it. Because what happens when we run it? When we run the code, we're taking the code, the machine language, this binary code, and then we access it at the stored location. Now when you double click on it or type in its name and press enter, you take that secondary storage device, take the binary information, and you load it up into memory. Why do we need it into memory? Because the CPU is communicating with the RAM, with the live memory. And whatever that code tells the CPU will fetch the information and then process that information, and that's what we call the executing of the information. So if you receive an email and it has an attachment, and that attachment is a virus, you can just click on the virus and delete it, and it's gone. The problem is when you double-clicked on it, and now it's active, now it's alive, now it's making modifications. It's looking at your passwords and sending it to Russia or someplace. Now you have a problem, okay? But until you run the code, you're going to be just fine. So when we're talking about syntax errors, when we're checking the source code for syntax errors, the compiler cannot check for logical errors. So the logical errors are going to be a lot harder to find because we don't find those by code. So how do we find logical errors then if we cannot find it by the compiler? The interpreter cannot see it. So let's say I have to add 5 plus 2 together. And by mistake I typed in 5 minus 2. As far as the expression is concerned, it's perfectly fine. There is nothing wrong with 5 plus 2 or 5 minus 2. So the computer doesn't know what is it that you want to accomplish. So if you don't know what is it, or the computer doesn't know what you want to accomplish, it will say that it is perfectly fine. But when your program runs, you don't know if it's correct until you test it, with different values and see, do I get the right results? And that's also what your homework assignment, the next assignment is about. What is the values that I need to send to the program? What are the proper values to send to the program in order to test the program for proper operation, in order to find logical errors? Okay. So they're a lot more difficult to locate. And that's when you need to look at the programming life cycle. How do you program? It's not just coding, but you need to design it, code it, and then test it. So RAM is volatile. We're just using it for storing temporary information. So if we turn off the computer, information is gone. That's why we call it volatile. So what is a real programming life cycle? Well, first of all, you read the problem, right? So that's where most people hate computer science, right? Because you hated math too. We all hated word problems. Because you have to read this long paragraphs or sentence and you have to make sense out of it. And you have to figure out, what do I need to do? And at the end, you might just need it to multiply two values together. But before you realize you have to multiply two values together, you have to understand what the problem was about. So first you need to understand the problem, and then you plan the logic. Right? So how do I convert Celsius to Fahrenheit, and how do I convert Celsius or Fahrenheit back to Celsius? Okay. So you need to plan it. You need to look at the algorithm. You might have to do some research on how do I find the volume of a sphere. You might not know that, but it is a set formula. So then you can find out that in order for me to calculate the volume of a sphere, I need to ask a user for the radius. And if the person gives me the radius, I can handle the rest of the calculation. But first we needed to understand that the user wanted me to figure out the volume of a sphere. Right? So in a problem, somebody might say how much water I need to get in order to fill up my football with water. And you would say, well, I don't know. Get some water and start filling it up until it overfills and then it's full. Well, in science, we need to look at it and we need to figure it out exactly. So that's when we need to understand it, not the user that requests or the client that requests the program. So you need to know how to calculate the volume of a sphere or volume of a three-dimensional object. So that's when you're planning the logic. So that's when you, relying back to all your math courses, your physics, chemistry, biology, all your calculus courses, that's why you need to take those courses. That's why it's not coding. Because coding doesn't start until you understood the problem. And based on your education, you understand how to solve that problem. And then you start coding based on whatever language you pick for that particular problem. Then you need to understand the compiler and the interpreter, right? So that's why we try to keep it the same version, because each interpreter, each compiler has their own little tricks how to make them work, how to make it work, and how to use them. So that's why last time we installed Visual Studio. But if you feel comfortable with some other interpreters, other compilers, other IDE environments, IDE is what gives you the interface for programming, and the IDE usually has a particular compiler already built into it. So if you feel comfortable with something else than Visual Studio, use that. Okay? By all means, this is not about learning a bunch of different interpreters. It is about learning C++. So whatever makes it easier. But I'm going to be picking one particular compiler because it is just not possible to talk about all of them. Okay, so the concepts are going to be all the same. So you need to look at a little bit of Visual Studio and how to use that. In order to get more comfortable, you might look at some YouTube videos while the course is just getting started. Try to look at YouTube videos on the compiler itself. So how do you use it, even if you don't understand what the code is, what those videos are talking about. So after we compile the code, then we need to test the program. Right? So that's when you have your assignment. What are the values? We have an imaginary program that we don't know who wrote it or what language is written in, and we don't really care. what we're looking at is, if I'm sending this program a data, can I get the proper result out of that program? So if I'm trying to figure out if the program adds positive numbers together properly, okay, then I'm not just feeding positive numbers to that program, but I might also feed negative numbers to the program, and I want to see if the program gives me an error message saying, no, this program is to evaluate positive numbers, so don't feed me negative numbers. If I'm testing a range of numbers, I want to test the program if it works between 0 and 10, including 0 and 10, then I need to know how to test those values. So let's say if we have Okay, so if we have a range, let's say 3 to 12, that's how we saw it in the math class, right? So what does that mean to us in the math class? In the math class, it means the number range starts from 3, but is not including 3, and it ends at 12, but it is including 12, right? So now how would you test this program if this program actually works properly? So I probably want to do something before 3, right? So I want to feed 2 to this program and see what it does. I want to feed exactly the border value. I want to see what it does if 3 is put in or processed by this code, because it should not process 3 as the part of the range. Because of this parenthesis right here, it shows that 3 is not inclusive. So then what I want to do is try something in between, let's say 7, and then I want to try 12 just to make sure that my program is processing 12 properly as an inclusive value to that range. And then I want to process or test this code with maybe 15. Okay, so for this range, if this is my code, I'm testing with 2, 3, 7, 12, and 15. So one range of operation, I'm testing it with 5 values. And now I can be certain that the code works the way that I designed this code. Okay, so we have this life cycle. So when we start a program or we have a assignment to solve, I guess. Okay, first you really need to understand the problem. So this is when I cannot help you with, because understanding the problem is part of the grade, right? So if you misunderstand the problem, that means you're going to write a bad code. You're going to write a code that doesn't give the right answer. So understanding the problem is part of the assignment. And then you plan your logic. Again, it is part of the assignment. It's part of this programming process. And then you write your code. So how do I know that you understand the problem properly? And how do I know if you planned your code properly or planned your logic properly? Now that's why for all assignments, you're gonna have to submit a flowchart, because the flowchart will tell me if you planned the code properly. So you have to submit your flowchart to show that you designed the code, and then the code itself to show that you wrote the code. Okay, so that's why the assignment requires your flowchart and pseudocode, because both of those going to be helpful in actually writing the code. Now, translating the code is just basically compiling it. So that's going to be a button click. So it's going to be very easy these days if we use the proper IDE. And after everything compiles just fine, now when we compile, we translate the code, we're going to find syntax errors. So if we mistype something, it's going to find it. So that's good because we can go back and fix it. But that's when the importance of testing comes in, because the compiler will not find logical errors. So then you have to test the program, and not just testing with any values, but like I showed you, sometimes you have to test it with many different values in order to test one single code for logical errors. And then that's when you basically submit the assignment. You put it into production. You only put it into production after you tested the code. And within the code, we're going to be required to document the code. So you have to have comments in the code. Why? Because even after testing, later on, we might find some problems. So then we need to go back to the code. And it might not be you. It might be somebody else. So that somebody else who maintains the code needs to know how your code performs or how your code operates. So then they're going to be relying on your documentation of your code. Okay, so that is the programming life cycle. It's a very important concept as you're approaching every single assignment, every single exercise in the book, or every single concept in the book. Look at it from this whole life cycle point of view. Because that's what makes you a professional programmer. Okay? Because you put in effort before you start coding, and then afterwards you're testing your code and you're finding your own errors, and specifically logical errors. Okay. So when you are planning the logic, you're basically building the algorithm. Building the algorithm means that you realize that you have to ask the radius of the sphere from the user. If the user doesn't give me that information, I'm not going to be able to calculate the volume of the sphere. And so you have to have this plan ahead of time, and that's what we call an algorithm. Okay. So if you cannot solve a problem on a piece of paper, you're not going to be able to solve it with a code or with a computer code. Okay. So what you want to do is have this logic, have the algorithm, and go through that algorithm and see if you can solve the problem on a piece of paper. And if you can, then you have a good logic, so then you can start coding the program. And so only when the programmers have developed the logic of a program can you start actually programming. Now, which programming language you're going to pick? Well, that's going to be up to you. In this case, in our case, we're going to be using C++. But in many projects, many programs, or many real applications, you're not using really one single application, one single programming language. These days, we use many different programming languages. Okay, so then we need to take that code, what we wrote, and then we run it through a syntax checker, right, or interpreter, and then we convert that higher level program, higher level language, to a lower level machine language that computers can understand. Okay, so after everything checks out, the syntax was fine. Then we start looking into testing the code in order to identify logical errors. Because like we said, the compiler cannot find logical errors. Okay, so this might take a long time. So this is not something that you can sit down in 5 minutes and everything are worked out in a short amount of time. Okay, so it's a process, and afterwards you have to maintain the code. Okay, so maintaining the program also has its life cycle, right? And you need to understand the changes. Sometimes you have to get the approval for the changes, because you might say this is going to work and it doesn't really work, and somebody with different background can see it better. So then you plan the changes, you actually put in the code, then you translate it, then you test it again, and if the test works out just fine, then put it into production, and then you go back into maintaining that new code. So how do we plan the logic? That's when we use pseudocode. Pseudocode is a simplified English in a strict format, or a stricter type of a format. Or we can use a more visual representation of the algorithm by using flowchart. Okay. So when it comes to flowcharts, the flowcharts have different symbols. So the input symbol or the output symbol is indicating that the user, there's an interaction from some outside source. It can be a file, database, or a user, but all that is an input. Okay. So the output is also a parallelogram, as the processing symbol is just a rectangle. Okay. And in order to calculate something, then we use the syntax of compute what? Compute calculated answer. Now this calculated answer is not really an English word. So this is when you not really writing an English sentence, but you start designing your code. So in this case, you can see that we have two words put together, and we'll talk about later on when we get to the specifics of a language. But most languages do not allow space for variable names. So in this case, as somebody's writing this compute calculated answer as original number times 2, in the pseudocode or in the flowchart, you're already writing the proper names for your variables. Okay, so that's going to be important to understand that you have to use the right variable names that later on you're going to be basically copy pasting into your code because you already named it properly. So one thing that you want to look at is if you have multiple words. Okay, so like right now we have this calculated and answer. Okay, now calculated starts with a lowercase letter. Answer starts with an uppercase letter. Okay, and that's what I'm going to be checking in your assignments. Okay, but this we call, okay, so if you look at this, it looks something like that, right? So let's say you say welcome Richland College. Okay, welcome Richland College is 3 separate words. If I want to store something into that variable, if I'm using that in my program, then I start welcome with a lowercase Richland with an uppercase, college with an uppercase, but there are no spaces in between. What we call, this looks like a camel, so this, what we call is a camel casing. So for variables, we're going to use camel casing. So throughout this whole course, when we talk about any, we'll define later on what an identifier is. So one of the type of an identifier is called a variable. So for all variables, we're going to use camel casing. Now, if we would use, and if you guys take the Java class as well, in other languages, we also going to have a different naming standard. Okay, so in Java, if we would say Welcome Richland College as a class, in that case, we would have capital Welcome, and then uppercase Richland, and then uppercase college, followed by all lowercases. So in this case, this is uppercase lowercases, uppercase lowercases, uppercase lowercases. This is called Pascal casing. Okay. So naming standard is camel casing. The first combined word is all lowercase, and each additional word that you concatenate to the first word, the starting character is capitalized. So then we also need to use flow lines, so we can look at which way the code is flowing. So there's going to be arrow. So we have shapes, and the shapes are connected with arrows. And then we need to have terminating symbols to show where the program starts and where it stops. Okay. So this is an important slide right here. You need to, as you're reading through the chapter, make sure that you referencing this one slide. Okay. So this is where you see that the program to the left-hand side is a flowchart, the right-hand side is a pseudocode. Right now, you have to write both of them, even though they are all the same. Okay. So when you write the pseudocode, you need to look at the indentation. So focus on the indentation. What is indented? So start and stop is the most left words in your pseudocode. Everything is indented at the same level. If you look at the compute calculated answer as original number times 2, original number times 2 belongs to the sentence above it. So to show that that still belongs to the sentence above it, you indent the original number times 2. So anything that belongs to a block of statement is indented, and the block starts at the left-hand side. Okay, but the start and the stop terminating words are the most left words in your pseudocode. Now, if you write this flowchart, the flowchart doesn't have indentation. You don't need to worry about that. But in the flowchart, you need to make sure that you use the proper shapes for the proper processes. But that's a really good chart showing you how they relate to each other. They both say the same thing. And eventually, as a programmer, you're going to pick either or. At the end of the semester, you're not going to do both of them. Right now, I'm kind of forcing you guys to do both of them so you can eventually make your own decision which one that works for you best. And some of you are going to pick flowchart, and some of you are going to pick pseudocode. But right now, you have to do both of them. Okay. So when we talk about repetition, computers are really good at repeating things exactly the same way over and over and over again. So instead of writing things many times over, let's say 10,000 times over, right? Why would you write something 10,000 times over when you can just write it once and iterate through that one block of statements? So we call that repetition. If we want to repeat the same operation, the same process multiple times, then we can just use repetition. So another concept here is variables and constants. So the chapter explains this whole naming, how do you name variables, and that's what you need to focus on at this point. So we have variables. Variables are named memory location whose contents can vary over time. A variable is also called an identifier. Right? So last time we talked about that we have a memory location. Okay, we have many memory locations. So let's say this is 0x1 and 0x2. Okay, and we would like to store 5 in this memory location and 15 in this memory location. Okay. Now remember, RAM is random access memory. Applications using that memory all the time, all over the place. So how do we figure out where are we going to store our values? So here, instead of just saying memory location, we're saying X equals to and Y equals to. And the operating system will manage how or where to load, where to find space for these variables or for these values. Now, how does the operating system know how much information you need to set aside, how much space you need for a value? Well, that's when we need to look at the identifiers have types. So if both of these types, and later on, again, we're going to define what data types are, but let's say we're going to say int. Int means it's an integer. It's a whole number. All right? So if we say the data type is an integer, that means this is going to be, let's say, 4 bytes. So the operating system looks at what is this pointer, right? The pointer is the variable. The pointer is the named memory location. But the operating system looks at what type is that. Well, that is a integer type. An integer type is 4 bytes. I need to find 4 bytes in memory and reserve it for that one memory, for that one variable. Okay? And that's why in your homework assignment you're going to see some things like a variable is a number. Now, can I assign a string to a number? Well, the string is a different size than a number, so no, I cannot assign a string when I'm specifying that it was a number. Okay, so the data type matters, and then we need to know what data type we are pointing to. Kind of like a drawer, right? You have a drawer for socks, and you can only store socks in that drawer. Somebody comes in and tries to store shirts in that drawer, and you're going to say, no, you can't store that. This drawer is only for socks. So that's where the assignment is going when you are just basically answering questions based on this data type, based on this variable. Can I assign a value to that variable? Okay, so variables have data types. The data type determines what can be stored in that variable. Okay, so we have the camel casing and the Pascal casing. So that's where you have the camel casing when you have all lowercase word, and then the next word concatenated to it starts with an uppercase. In Pascal casing, all concatenated words start with an uppercase character. Okay. Assignment is when we actually store something, right? So if this would be in a pseudocode, here we are calculating, right? And what do we do with the result of a calculation? The result of a calculation is assigned to the calculated answer. Now, what is calculated answer? Well, calculated answer is pointing to somewhere in memory, let's say 0x3, okay, pointing somewhere in memory because it is a variable, and that variable has its data type, so we know its size of it. So the results are associated or assigned to that memory address. And how do we find that memory address? Through the name of the variable. So that means we're going to have original number. So original number is also pointing to a memory area, a different memory address, let's say 0x5. And that has a value stored in it 5. So when we do the calculation, how do we do the calculation? We are going to memory address 0x5, and then we're fetching the value from 0x5. What is the value in 0x5? It's 5. So then we are multiplying 5 by 2. So what is it that we are assigning to a calculated answer? We are assigning 10 to calculated answer. And then, what if we change this? Remember, this is a variable, so somebody can change that value. So now it's 15. So now when we are doing the same calculation, we are assigning original number 15. So when we're fetching the 15, where is 15 stored at? It is stored at 0x5. That's the actual memory address. It is in RAM, random access memory. We don't need this after we turn off the computer. We need it right now to perform the calculation. So we're fetching 15. 15 times 2 is 30. So then we go, calculated answer is replaced. So 10 is replaced with the new result of the calculation. And now 0x3 memory address contains 30. That 30 is pointed to by calculated answer. So the assignment operator right now is a equal sign. When we're talking about a constant value or a named constant value, we can only assign a value once. So after we assign the value, you can't change it. You cannot change it. What's a magic value? A magic value is an unnamed constant like 0.08. And the problem with that is you have no clue what it means. So it still needs to be stored, but you don't know what it refers to. So you just call it a magic number. Okay. So you have arithmetic operations that the computers perform. So the standard operations, the plus, minus, asterisk, or the multiplication, and then the division. Every operator follows a rules of precedence. So that's when you need to remember from elementary school something like please excuse my dear Aunt Sally. Right? So we have an order of precedence. So when you say please excuse my dear Aunt Sally, that means the parentheses come first, okay? And then you have the exponents evaluated next. And then you have the multiplication. There's supposed to be an asterisk right there, okay? Multiplication, then division, then addition, and then subtraction. So operators also have their order that needs to be maintained by the computer. And you, as a programmer, you need to understand that order of precedence. Okay. Okay, so let's see. On my blog, I have some let's see if, no. Look, spot. Yeah, there it is. Okay. So on my blog, there should be some explanation or kind of like an exercise on order of precedence, if you guys interested in that. If I could ever find these. Anyway, you guys should be able to find it. There it is. Okay. So this is how really computers work, and I have some YouTube videos as well explaining how computers really work. And original calculators, you actually had to work with original calculators. The first TI calculator, you had to type in the numbers first, and then in logical order, you had to type in the operators. Okay, so if you want to go deeper into this, you guys can look at these things. I have some videos on Turing machine, how Turing machine works, and a lot of different things. So if you guys need more help, you guys can have more help based on those videos. Okay. So then you need to talk about the data types, and that's what the chapter is really talking about, the different data types. Okay. What is a constant or literal number? So named constants, right? So now we not just have a value, that we also have a name that's meaningful. So we might have tax rate. Tax rate is 8.25%. If you just say 0.0825, it doesn't mean anything. If you say it's a constant, but it is the tax rate, then it has some meaning. It's not just 0.0825, but you know that that is the tax rate. String constant is you're assigning a string. So the title of this college is, or the name of the college is Richland College. So there is a string constant. It never changes. You don't want somebody just to come in one day and change the name of the college. Okay, so the data type describes the kind of value the variable can hold, how much memory the value occupies, and the types of operations that can be performed with that stored data there. And that's when you do the homework on, this is a number, can I put in a string? No. This is a string, can I put in a number? No. Okay. This is a number, can I assign a number to it? Yes. Okay. So this is a number data type variable. Can I assign another number data type variable to it? Yes, you can. Okay. So you're just basically giving an answer, yes or no, to those kind of questions. Okay. So these kind of things, you really need to go through in the chapter. You read through the chapter. There is nothing complicated about this. You just try to understand variables and what data types are. Now the concept of garbage value is going to be interesting, because When we declare a variable, there is garbage in it because we haven't initialized it yet. So declaration is not the same as initialization. So when you declare a variable, it's uninitialized, so it has a garbage value in it. When we get to use the compiler, I'll show you, and we're gonna do some exercises with that. Right now, just try to understand the concept and the terminology. Okay? There are more values or more definitions to learn. An infinite loop you can't get out of. Right? Repeating the statement so many times you can't get out of it. A sentinel value is going to be a value that is, okay, when do we want to stop? Think about a sentinel value when you're playing games and you lost the game. It says, do you want to play another one? And you say yes. And then you lose that one. It says, do you want to play another one? You say yes. And then you lose that one, and you're going to say, do you want to play another one? You say no. Okay? So that's sentinel, what you're looking for to say, how many times I want to repeat the same things over and over and over again. What's going to tell me to get out of it? What's going to be that sentinel? And sometimes we have dummy values, okay, that can be selected as a stop sequence or stop value. So maybe you're reading a lot of age values, a lot of ages for people. You know they're not going to be a negative age. So in order to show the computer that I'm not sure if I'm going to process 5 people's ages or 15 people's ages. But when you see a negative value, that's the end of the list. Okay, so those are kind of like dummy values, or we're going to call them like flags. Okay. Testing values is when you're making decisions. We're going to use the diamond shape in our flowchart for decision making. Okay, so the decision symbol is going to be the diamond shape. Okay, so again, it's going to be important to see that we have the original number is it equal to 0? Well, we don't know because we are asking the input from the user. So the user is looking, so coding time, you don't know what the user is going to type in. What you can do is test if the user typed in the proper value. If the user did type in the proper value, then you stop the program. If not, then you do some calculations and then output the calculated answer, and then you might ask a user for another input value. Okay, so in this case, you're looking for 0. If the user types in 0, that's going to be the value that will kick you out of the code and ends basically the program. So in many programming languages use the term end of the file, or EOF, and that is a flag, that is a marker. Okay, and that marker shows that you processed the whole file. You can stop running now. And then you guys can look at the different programming languages and the history. Okay, what we learn in this class is the procedural programming, and in Java you're going to be focusing more on the object-oriented programming. So we look at procedural programming as a prerequisite to object-oriented programming. So we're going to, even though C++ is object-oriented, you guys are going to learn it from a procedural programming point of view, and that's going to help you understand object-oriented programming if you do take Java later on. Okay, so machine language is 0s and 1s. You do not want to remember how to write 0s and 1s. Assembly language, that wasn't very user-friendly. That's where I was moving AX0 and BX0 and A low 3. Right, not very user-friendly. But when you have higher level languages, what we did right now with the C++, then you look at calculated answer and you just say, whatever value you give me, multiply it by 2. It's much more human-friendly. Okay, And then there are interpreted languages, and that's when you're going to have something like Python. So I would say, you know, you guys start with C++, then you would take Java, and then you would take a Python class, and then you would have this whole evolution to compare what is the difference between programming languages and which programming language you would pick to develop a given application. Okay, so then you can make your decisions at that point. Okay, but that's pretty much what this chapter is about. Okay, so before we do any kind of programming or thinking about programming languages, what I would suggest that you guys can also just practice operator precedences and variable assignment in a simplified way if you have your command line. Okay, so this is my command line, right? So if you click on the start button and just type in CMD, CMD will start this command prompt. Okay, so you do want to practice command prompt or this terminal type of computers. So more you get away from mouse, better you're going to be in computer science. Okay, so if you look at, let's say, your environment, so we have set. Set shows you see all these names, okay, and then equals to and some other value. Okay, so this is what Microsoft is using as your environmental variables. So let's say in this case there's a WinDear equals to C:\Windows. So I can display that value echo, and I say the name of the actual variable, and this percentage before and after it says, so echo means display back whatever I'm typing. In this case it means display back the value of a variable. So don't display WinDear, but what is in that WinDear. Right? So if I don't put in the percentage in front of it and behind it, when I echo WinDear, it just says, well, I need to display a string of characters. But in this particular syntax, so this is the syntax of this shell or this terminal window, if you put a percentage before and after any word that you see, okay, any word that you see here before the equal sign, you can actually display the value of these variables. Okay, so I need to know what is my system drive. Then I would just type in system drive, and it tells me it's C. Where does C come from? Because I display the values of these variables by typing in the set command. Okay, so here, let's say we're going to set a variable. Okay, we can say set variable 1 equals to 2 plus 3 divided by 7. Okay, so now how do we see what's in that variable? We say echo, what is the value of this variable? Well, something is not right, right? I wanted to do a arithmetic operation here. How come it doesn't add 2 plus 3 divided by 7? Well, we didn't say we wanted to do any kind of an operation, right? We said equals to and all these characters. So 2 is a character, plus is a character, 3 is a character, that / is a character, and 7 is a character. So it stored that as a string. Now if we go back, if you just press on your up and down arrow key, you go back in your history, so you don't have to retype everything. Okay, so the up and down arrow key on your keyboard shows you what you typed in before. So I go back to my set statement, and here I'm going to put in a /A. Now in this case, I'm saying that set is the utility, needs to do an arithmetic operation. So the /A tells the set application, don't just assign whatever follows the equal sign as a string. That's not a literal string. What that is an actual operation. So how come we got 2? Well, we got 2 because we had to perform the division operation, and later on we'll learn what an integer division is. But 3 divided by 7 was performed first. 3 divided by 7 is 0. But it is an integer division, so it's taking it as 0. So we're adding 0 to 2, and that's 2. Okay. So let's change this to, let's say, 6. Okay. The result is still 2. But if I change this to parentheses, right? Remember, please excuse my dear Aunt Sally. What happens now? Please or parentheses needs to be evaluated first. So now we have 2 plus 6. 2 plus 6 is 8. 8 divided by 7 is over 1. Right? So the result is 1. So 2 plus 6 divided by 7 is not the same thing as 2 plus 6 in parentheses divided by 7. The parentheses elevated the precedence of 2 plus 6 above the precedence of the division. So 2 plus 6 was performed first, and that was 8. So now we divide 8 by 7. So the result is 1, ignoring all the fractional values. And later on we'll learn when we get into C++ why that really happened. But right here on the terminal, without knowing C++ or knowing anything, you can practice this, and there's nothing going to hurt your computer. So this is a safe environment to practice something like this. Okay. So here you can say echo, or maybe set name equals Zoltan, and then we can say echo. I want to echo the name, and maybe after that I want to say Richland College. Okay, so it says it did not say name Richland College. It actually fetched. It was fetching the string from the variable called name, and the echo command concatenated the value of name with the literal string that I followed, the variable, which was Richland College. Okay, so you guys can practice this. Hopefully you guys understand this, and if you have any question on this kind of variables, then use the discussion board, and have some questions or on flowchart symbols or pseudocode, any kind of a concept that's not specific to the assignment, but specific to concept discussed in this particular chapter. Okay, so does anybody have any question at this point? Okay, so we ran a little bit over time, but sorry about that. So if you guys have any questions, post it on discussion board, and you guys have a great day.